Hello everyone. So today we're going to go over section 2.1, the tangent ratio. So trigonometry is the study of relationships between the sides and angles of triangles, particularly right triangles. So today we're going to be looking at the tangent ratio, which is an example of a trigonometric ratio. So here on the right we have some nested triangles, and we'll note that they all share the angle A right here. And we'll be examining the ratio of the opposite and adjacent side to the angle A for each of the triangles. So for example, in triangle ABC, right here, we will see that the opposite side, BC, has length 1, and the adjacent side, AC, has length 2. And then similarly, DE, length 2, AE is length 4. So once again, that's DE and AE, followed by FG, which has length 3, AG, which has length 6, and finally, for HI and AI, we have the lengths 4 and 8, respectively. So notice that all of these ratios are actually just 1/2. And the idea is that so long as the triangle we're working with is a right triangle and the angle stays the same, then the ratio of the opposite side over the adjacent side will remain the same as well. And that is the tangent ratio. So here we have the definition. The tangent of angle A is equal to the length side opposite of angle A divided by the length of the side adjacent to angle A. So we can also look at a triangle just like this. And we're actually going to label the side. So here on the bottom left, we have angle A. And then on the bottom right, we have the right angle. The side that's opposite from the right angle is the hypotenuse. It is also, of course, the longest side. And we have the side that's opposite from angle A, and that will be the opposite side. Just adding some shorthands here. And finally, this third side is the adjacent side. So let's look at some examples. Here we have a triangle ABC. We're going to try to determine tangent A and tangent C. So let's look from the perspective of A. Then the 3 will be the opposite side, and the 4 is the adjacent side. We can also look from the perspective of angle C. Then, of course, the 3 is adjacent to it, whereas the 4 is opposite from it. And, of course, in both instances, the length AC here, that is the hypotenuse. Okay. So let's start by finding tangent A. That will be the length of the opposite side, which is length 3, divided by the length of the adjacent side, which is length 4. So simply 3/4. And then for tangent C, we have the reciprocal, and that is 4/3. Okay. So what makes the trigonometric ratio useful is that along with a calculator, we can actually find these angles. So let's look at a second example. We have GHJ of our triangle here. We're going to find the measure of angle G and angle J, given that angle H is the right angle. So again, we'll start by labeling our triangle. So here is angle G. So this will be the opposite side. This will be the adjacent side of angle G. And then we can do the same thing for angle J as well. And of course, in both instances, the length this side will be the hypotenuse. Okay, so very similar to the previous example. Okay, so let's start with tangent G is equal to 6/4. Okay. Which we can reduce to 3/2. Okay. So what we'll then do is, since we have tangent G, we want G by itself in order to find the angle measure. We will use the inverse operation. So inverse tangent or arctangent which will eliminate tangent, which is in front of the G. So we'll get G by itself at the end. So since it's an equation, whatever we do on the left-hand side, we'll do on the right-hand side as well. So we also have inverse tangent on the right-hand side, and it will be of 3/2. Okay. So something that looks like this. So after all of that, on the left-hand side, what's going to happen is inverse tangent and tangent will eliminate each other. So just like that. And we'll be left with G itself. And on the right-hand side, we have arctangent, or inverse tangent, of 3/2. Oops, sorry about that. That's okay, there we go. All right, so this will be 3/2. And for that, we can use a calculator. So here we go. Just going to go ahead and use arctangent, or inverse tangent, of 3/2. And we'll get 56.31 degrees, so approximately that. We're going to round to 56.31 degrees. Okay, now we can do the same thing for angle J as well. So tangent J is equal to, of course, 4/6, the reciprocal of the previous question. Since opposite and adjacent side simply switches. Okay, and so J is going to be equal to inverse tangent, or arctangent, of 4/6. So we don't need to reduce here. And then we can go back to the calculator. Here we go, and we have arctangent of 4/6, and which will give us 33.69 degrees. So notice that we are working with a right triangle, so the sum total of these two angles, G and J, has to add up to 90 degrees because the sum total of the angles inside of a triangle has to be 180, and the right triangle accounts for 90 degrees of that. Okay, so that is to say, G plus J is equal to 56.31 plus 33.69, and we'll get 90 degrees. Okay. And this will hold true for other right triangles of this type as well. Let's look at another example. So here we're looking at an angle of inclination question. So it says here, in the northern hemisphere, solar panels should face south and tilt at an angle of inclination approximately equal to the site's latitude. So in the latitude of Vancouver, BC is approximately 49 degrees. We're going to determine whether this design is best for Vancouver. So in this case, we're actually looking for the right triangle first. So we have the hypotenuse, so that will be parallel to the panel, the side here, and the height, which is 12 feet. So what is important to note is that 32 feet, which is labeled at the bottom there, is the entire length, and we are only going to be using half of that. So this is 16 feet. Okay. And we want to find out this angle of inclination, and we'll call that angle A. So to the left, we have tangent A is equal to simply opposite over adjacent. So in this case, it's going to be 12 over 16. So A by itself is going to be inverse tangent or arctangent of 12 over 16. And then we can get A by itself. So arctangent, or inverse tan, 12 over 16. And we get approximately, so rounded, 36.87 degrees, which is not quite 49 degrees, so maybe it's not the best. You can increase the angle. Okay, so let's look at one more example. So it says here, a 10-foot ladder leaned against the side of the building with its base 4 feet from the wall. So it's best to just go ahead and draw the diagram. So here's the ladder, here's a wall, and here is the distance from the base of the wall to the base of the ladder. And we're looking for the angle that the ladder makes with the ground. So this is the angle here. We're going to call that angle A once again. Again, the ground and the wall makes a right angle, and we have 4 feet here and 10 feet for the ladder. Okay. So we don't actually have the opposite side. So if we go ahead and label the 3 sides, this is the opposite side of angle A, and we don't know what that is just yet. This will be the adjacent side, that's 4 feet, and the hypotenuse is 10 feet. So because we do not yet have the other trigonometric ratios, we are going to be relying on tangent for now. We need to first use the Pythagorean Theorem, so a squared plus b squared equals c squared, to find out what the opposite side actually is. So we're going to go ahead and substitute. We have 4 squared plus w squared for the opposite side, the wall, and then 10 squared on the right-hand side. 4 squared is 16. W squared, we can just leave that for now. And then 10 squared is 100. So w squared is equal to 100 minus 16, which is 84. and w is going to be equal to the square root of 84. So we could use a calculator to find an approximation of this, or we can just leave it as a square root for now. Since in the next step, what we're going to do is go tangent A is equal to the opposite, which we just found to be the square root of 84, and then divided by the adjacent side, which is 4. And from there, we can isolate and get A by itself. A is going to be equal to inverse tangent or arctangent of the square root of 84 divided by 4. Okay, just like this. Okay, so A is going to be equal to, so inverse tangent square root 84 divided by 4 is going to give us 66.42 degrees. And again, we rounded to the nearest 100th instead of the nearest degree. So it would have been just 66 degrees if we rounded to the nearest degree, as the question says here. But regardless, that's the steps for showing the question. And so that's it for today. So once again, we went over the tangent ratio and how to find angles using the tangent ratio. And so thank you for listening.